So far, all the code that you've written in this course has been what I'd call use and throw. You'd write the code to calculate something, the length of a string, for example, and then you hit Shift Enter. That code remains in that cell. There is no way to access it again. There's no way to reuse that bit of code. Code reusability is an important programming construct, and code reusability is achieved using functions. Now, we've already used functions that have been created by other people and made available to us in Python. For example, len is a built-in function that we've used several times. But often when you're writing your own code, built-in functions may not have the complete functionality that you need. You want to write code for something useful in a reusable way, you need to be able to define your own functions. And obviously Python, like any other programming language, allows you to do this. Let's define our first function. A function is defined using the def keyword. It's followed by the function name, which here is print underscore something, and then brackets. Following the function, we have the colon, after which we'll write all the code which belongs to that function. This function has exactly one line of code which prints the word something. Notice that the code within the function is indented just like we indent code within if blocks or for loops. What we see here on screen with the def keyword is the function definition. The function definition basically contains the name of the function and all the code that you want executed when this function is called. Once you've defined a function, you can call the function by name in order to run the code that lives within it. Calling a function by name is called invoking a function. Here we are invoking the function print something. When you invoke a function, the code within the function is executed. Here is just one line of code. We print out the word something. Now it's pretty obvious that this function is kind of boring and it doesn't really do anything. Each time you invoke the function, it'll simply print the word something. We can make this function a little more interesting by actually having it print a message that you pass into the function. In order for the function to receive information from you when you call the function, you have to set up the function definition a little differently. Here we have a print text function. Note the def keyword indicating that we're going to define a function. You can pass in some string to this print text function and it will print that message out to screen. This information that you pass into the function is sent in via the input argument. This function takes in exactly one input argument and that is in the text variable. Then you simply print that variable out to screen. We'll now invoke this function by passing in a string message that we want to print out to screen. Here our input argument has the value hello world. When the print text function that we've just defined is invoked, this hello world value will be stored in the text variable and we print out the text to screen. The cool thing about input arguments is it allows you to customize how your function executes the code. You can pass in any text you want here and that is what will be printed out. A function in Python can have any number of input arguments. There is no limit. Here we've defined an add numbers function. It takes in two input arguments stored in the variables a and b. The body of this function simply prints out the sum of the numbers a plus b. Once we've defined a function, we can then invoke it with any numbers. We add numbers 11 and 22, we get the sum 33. You can pass in different values for the input arguments as well. This is called invoking the function with different input arguments. Here the sum is 26.5. Let's now see something interesting about functions. Here we've defined two variables, a and b, which hold the value 10 and 20 respectively, and we've defined a function as well. This is the add function and it takes in input arguments x and y. The code within this function performs an addition operation, but it does so on variables a and b. The result that is printed to screen is a plus b. This is clearly not what we want the function to do. We wanted to add the values that were passed into the function. This function is not doing that. We'll now invoke the add function by passing in the values 10 and 20. Now the interesting thing here is our add function will print out the right answer because these are the same values that are present in the variables a and b. So the answer will be 30, and you might think that your function is working correctly, but really it isn't. Try with a different set of input arguments and you'll see that the answer is still 30. This is because the function as we defined it is adding a and b. It's not adding x and y, the input arguments that we passed into the function. This is something you need to watch out for when you define your functions. Make sure your function operates on the variables that you want them to. We'll now define a subtract function which subtracts one number from another. It takes as its input x and y, and it will subtract y from x. We can invoke subtract by passing in values for x and y. Here the result is 11, that's correct. We can also invoke subtract by passing in variables which hold values. For example, we can define two variables a and b and assign them values, and we can call the subtract function by passing in a and b. Subtract will operate on the values held in the variables a and b and give us the result. 34 minus 12 is 22. Now, what if we want to store the result of the subtraction in a variable? Here we call the subtract function by passing in a and 10, which means we will perform the subtraction 34 minus 10. The value 34 is held in the variable a. But more importantly, we want the result to be stored in the result variable. 34 minus 10 equal to 24 is printed to screen. Let's examine what's in the result variable. You'll type out result on screen and you'll hit shift enter and you'll find nothing. It's pretty clear the result variable doesn't hold anything. It definitely does not hold the result of the subtraction. If you pass in result to the type function, we'll see what type of variable this is, and it says none type. The none type is a special Python value, which is the equivalent of null in other programming languages. If you've used C or Java, then you know that null basically means that variable has nothing in it, and that's what none indicates. Basically, our subtract method simply printed the result of the subtraction on screen. It didn't really return anything. In order to have functions return some value, you need to explicitly specify a return statement. Here we define the subtract method once again. We store x minus y in the result variable. We then print the result variable to screen and return the result variable. Notice the keyword return. This is the statement that you'll use to return information from functions. Now, if you invoke the subtract function returns a result, and this result can be stored in a variable. It will also print the result to screen, and if you examine R, you'll find that the result 6 has been stored in R as well. We'd spoken earlier about the fact that a function can have as many arguments as it wants to. There is no limit in Python. Here we have a function where we pass in 5 different arguments, A through E. We perform some kind of calculation with the numbers, store the result in the result variable, and then return the result variable. Now let's go ahead and invoke this function, but we'll pass in values only for 4 out of the 5 variables. Python uses the position to assign values to the variables that are in the input arguments, which means A gets the value 2, B gets the value 3, C gets the value 5, and so on. But we have just 4 values and 5 variables. If you do not specify values for all the arguments of a function, that function invocation will throw an error. The error message is actually pretty clear. The function is missing one required positional argument E. In Python, you can also specify input arguments by name when you're passing them in while invoking a function. We'll call the same function with many arguments, and notice that we've specified the name of each argument and the corresponding value for that argument. A is equal to 2, B is equal to 3, all the way up to E equal to 2. When you invoke a function which has many arguments, using the argument name to specify its value makes for code that is much more readable. Now, it's also possible to have a function which takes in a number of input arguments, but some of these arguments have default values. So if you omit an input argument, it'll take on its default value. Here we have the print num times function, which takes in your name and the number of times you want your name printed. The default value for the num input argument here is 1. So if you don't specify a value for num, it'll take on the value 1. The actual function body is very simple. You simply use a for loop to iterate num times and print out the value in the name variable. Now we'll take a look at the different ways in which we can invoke this print num times function. Here we are calling print num times. We pass in the name Yukti and we specify 6 as the value for the num variable. When a default value is specified for an input argument, you can still choose to pass in some other value when you invoke the function. Num will have the value 6 and print num times will print Yukti 6 times as you see on screen. When you invoke functions which have default values, you can omit passing in a value for the variable which has the default. Here, you can simply omit the value for num. This will print Pranoti exactly 1 time. Num will take on the default value of 1. Let's take a look at another example of a function which has default value specified as a part of its input arguments. Here the greet function has 3 input arguments: the name, a greeting, and the number of times we want this printed out. Both the greeting and the num times input argument have default values. These arguments can be omitted when we are invoking this function. The name argument does not have a default value. A value for the name argument has to be specified when this function is invoked. We'll set up a for loop to iterate num underscore times and print out the greeting and the name of the individual. Let's see the different ways in which this function can be invoked. We invoke the greet function and pass in only the value for the name variable. We omit the greeting as well as the num times. This means that hello Akash, hello being the default greeting, will be printed exactly once. The default value for num times is equal to 1. We can also invoke the greet function by specifying a value for the name input argument. Here it is Akash, and also a value for the greeting input argument. The greeting is Namaste. We can omit only the num underscore times. The num times variable will have the default value 1. Namaste Akash will be printed out exactly once. You can also invoke the greet function by specifying a value for the name variable and the num underscore times variable. You can omit the greeting because it has a default value. This will print out hello Akash 3 times. The function uses the default value for the greeting and the value of 3 for num underscore times. This is what we passed in. You can also specify values for all 3 of the input arguments. This will print out Namaste Akash 3 times. Python has a rule that input arguments which have default values have to be specified at the very end of the argument list. Here we have the greeting argument which has the default value hello, but num underscore times does not have a default value. This is an error. This Python syntax is incorrect. You cannot have a non-default argument follow a default argument. Specifying the name of the input argument while invoking the function is entirely optional. Here we call the greet function and specify values for the name, the greeting as well as num underscore times, but we haven't explicitly named our arguments when we invoke the function. These are all positional arguments. This function invocation will print good morning Namrata 4 times. You can also invoke functions by having some positional arguments and some named arguments. Here, the arguments for the name and the greeting are positional. Num underscore times is a named argument. This prints out good morning Namrata 4 times as expected. Python has another rule that you need to follow when you invoke functions. You first specify all the values for the positional arguments, and then after that you specify the values for the named arguments. You can't mix and match these. Notice that this is an error. A positional argument follows the keyword argument, the named argument. You can't have greeting is equal to good morning, which is a named argument or a keyword argument, followed by just 4. You have to pass in the value 4 as a named argument or a keyword argument. When you first start learning about functions, novice programmers often find this part confusing. What if you change the value that you've assigned to a variable within a function? Will it be reflected outside the function as well? Now, there are some nuances here, and we'll see what those nuances are using examples. Let's take an example of a function where we are going to modify the values of the input arguments that have been passed into it. Modifying values within function, it takes in two input arguments, a, b, and c. Notice that within the function, we've assigned new values to a, b, and c. The new values that we've assigned are an integer, a string, and a boolean. Once we've assigned new values to these variables, we'll print out these values of a, b, and c. We have a string to be printed out. Within the string, we've specified %s as the placeholder, which will take on the values from the variables a, b, and c. We'll now invoke this function by passing in the input arguments in the x, y, and z variables. We'll first initialize the values of x, y, and z. X is an integer, y is a string, and z is a boolean. And really, what we initialize the original variables to does not matter here. You can change the order of this initialization, and this example will remain exactly the same. This is something that you can try out. I'm now going to invoke this function by passing in the values for x, y, and z as the input arguments. Once this function has been executed, we have assigned new values to a, b, and c, and here are the new values of a, b, and c as seen from within the function block. The assignment of new values to the input arguments within the function updates the values that are stored in those variables, as you can see from the a, b, and c values that are printed out on screen here. Now the question is, you modified the values of a, b, and c within the function. How does that affect the variables x, y, and z which are outside the function? Remember, we had passed in the values of x, y, and z when we invoked the function. When you print out the values of x, y, and z, you'll see that they still hold their original values. The modifications that were made to the input arguments inside the function did not affect the variables that we passed in when we invoked the function. Within the function, we performed an assignment operation. We assigned new values to a, b, and c. This assignment operation within a function does not affect the values of the variables outside the function. This statement that I just said holds true even if the variables outside the function have the same names as the variables inside the function. We initialize three variables a, b, and c. These variables are outside the function, and then we pass in these variables to the function invocation. Now, it's important to note that the a, b, and c variables that we modify inside the function are not the same as the a, b, and c variables outside the function. So when we assign new values to a, b, and c inside the function, they are actually different variables than the a, b, and c that we've initialized outside the function. Now that we are outside the function, if you look at the values within the original variables a, b, and c, you'll find that they remain unchanged. When you're within the function, the a, b, and c refer to the input arguments. These input arguments hide the fact that there is an a, b, and c declared outside the function as well. Now, so far, we've worked with input arguments that are primitive types, strings, numbers, boolean, and so on. However, if you have an input argument that is a list, things behave a little differently. We'll initialize a list here globally, and then we'll go ahead and define a function that performs an operation on a list. This is going to add a new element to the list that has been passed into that function. Sum underscore list is the variable name of our input argument, and to that list, we append the name Kishan. Now we'll invoke this function by passing myList as the input argument. Now, within this function, we've changed what's in the list. We've appended a new element to the very end. If you print out the contents of my list, you'll see that the list has actually changed. Within our add to list function, we called sumList.append and appended the name Kishan to our list. Outside this function, when we print out the contents of my list, Kishan has actually been appended to the very end. So if you're adding new elements to a list that has been passed into a function or removing elements from it, those will affect the original list. Let's take the example of another function where we modify the elements in a list. Here we call sumList.pop twice in order to remove the last two elements at the very end of the list. Now, if you invoke this function on your myList variable that you had set up earlier, you'll find that the original list has been updated. You can print out the contents of my list now and notice that the last two names have been removed. Just like modifying a list, adding and removing elements from a list affect the original list that has been passed into a function, the same is true for dictionaries as well. Here we've set up a dictionary with student details. This is for the student Priya. We'll now go ahead and create a very simple function called add phone number. This takes as its input a dictionary called details and it adds a phone number to the dictionary. This is a function which modifies the dictionary passed in. It adds a new key to this dictionary. We'll go ahead and invoke this function on the student details dictionary, add phone number. And now if you check out the value of student details, you'll find that it has a new key within it. The phone number is present in this dictionary. The original dictionary has been modified. Removing a key from a dictionary within a function also modifies the original dictionary which was passed into the function. Here we have a delete address function. This takes in a dictionary called details and it removes the address key from the dictionary. This is the first time that we've encountered the del keyword. The del keyword basically says whatever is present for address, just remove that key and the corresponding value. Del keyword can be used to remove a particular key value pair from a dictionary. It can also be used to free up memory space that's associated with a variable. Let's say you have a variable that's pointing to a huge list. That list has, say, 100,000 items. You don't need that list anymore, but you still want to run the same Python program. You would use the del keyword on that list and then basically have Python free up the memory associated with those 100,000 elements. Invoke the delete address function and pass in the student details dictionary. This will actually remove the address key value pair from student details. You can test this out by printing student details to screen. Instead of that, we'll go ahead and delete student details itself. Here, student details is a very small dictionary. It doesn't really take up much memory. However, if this was the one which had 100,000 elements and took up, say, gigabytes of memory on your machine, in order to free up this memory, you'd simply call del and pass in the name of the variable, and that memory would be free for Python to clean up. Once you've called del on a particular variable, you can't access that variable again. So now if you try to access student details, you'll get a name error. The name student details is not defined. It's like it never existed. Let's now see an example of how variable names work outside a function and inside a function. Here we've defined three variables, some num, some string, and some list. And we've assigned it to three different values, one numeric, one string, and a list. These variables are defined outside any function. These variables are set to be in the global scope. We'll first confirm the values of these variables by printing them to screen. Okay, these variables look fine. Let's now define a function which takes as its input argument some num, some string, some list. These are the names of the variables of the input arguments to this function. The variable names of the input arguments are exactly the same as the variable names that we've declared outside the function, the variable names in the global scope. We've spoken about this earlier. These input arguments are variables that are in the local scope that are defined only within the function. The print statement that you can see within this function can only access the variable names which are its input arguments. Because the input arguments have the same names as the variables in the global scope, these arguments which are in the local scope hide the variables which are in the global scope. Within the function, you'll only be able to access the local variables, some num, some string, and some list, not the global variables. It's easy enough to try this out. We'll call some function and pass in three values for the input arguments, 44 Akshay Kumar and 145, and that is what is printed to screen. The values of the variables in the local scope is what is printed to screen from within the function. The original variables that are in the global scope we can access from outside the function, and they hold the same values that they did before. But the print statement within the function printed out the values of the input arguments which are in the local scope.